anyways, let's continue on this Chapter 1 tutorial with Part 2. So in Part 1, we have stopped here with this coding. We made our big cube in the bottom and translate our smaller cube upper 10. Then they are just closed exactly at the same edge, and then we use our very thin this cube to connect these two. So even you cannot see the third part, but actually this is the three-part joint. So that is the here. And we continue. Let's first save as to our Part 2. So you can come to this repository. So from this OpenSCAD, from now on, I have our tutorial folder, and I have this snapshot model file for every parts we have practiced. Then you can starting from any point when you do your own practice. So as described here, so there's nothing big meaning on this two cube altogether, but actually we want to do our the car view. It's mentioned is aerodynamic, so if we put that just in the middle, looks like is our car is not quite similar. So what we will do is we will slightly shift the upper part from the center to the another the way. So if you see here on Part 2, first we have this the big part in the bottom, then we translate. So we use this 10 minus this 001. So let's make those comments. So you can see here, if you select all, then you can have these comments here. So let's leave that. We build this again. So 60, 20, 10. If you want to recover any the earlier code, you can just uncomment them. So first line is same. Ensure you should have our semicolon, and then use translate first. Remember, you can use tab, and then we use this manner. So, but we let is not only 0010. We want them to from this x to shift to the positive x5. So that is will give you this shifting the feeling. So 10 minus 0.001. So that is the effect on this two sentence. So we use one sentence to finish the translate, and then we did this the upper cube 30, 20, 10, and then also center true. Let's make our F5. So that is the same for now. So you can put that smaller. What this cylinder means? Cylinder is you cannot see them. So let's make this cylinder. Cylinder. H is height. Height is 3. R is radius. So the radius is 8. So let's make the 5. So we don't see anything here, but remember is you can use this way to have a look. So you add this percentage So you can see you actually have our cylinder in the middle. So with our radius is 8 and the height is 3, and the cylinder is starting from the Z axle is from 0. So that is the cylinder. So we use this as our wheel. You should notice that cylinder is hidden. So, but I already gave you the ways for you to examine some shapes inside. So let's continue. So we will move the cylinder out. So what we will do is from the X is no shift, Z no shift, but we move in the Y to the negative Y minus 20. So let's put that translate. You can keep this percentage mark for now, so that you can always see your hidden or covered shape. So in short is you always need this bracket, the open bracket, close bracket, and also you need this the open pairing and close pairing. So then have this. As long as you don't have this semicolon, is one sentence. Then let's see the effect. So it's exact shift 20 for the negative Y. So now we have our first the wheel. The wheel is now visible, but your car won't go anywhere as it's not properly placed. You need to rotate that. So consider is you move this and we need to rotate here. So we add another transformation. So add rotate. So how to rotate? We want to rotate to the vertical. So this consider is rotate by which axle. So that looks like you can examine here. If you want to rotate from here to here, that means it's from the X axle. So that means it's from here you want to give our 90. That is the degree, and 0 for Y, 0 for Z. Also, you need this bracket. So then you can put the translate here. Then let's do the preview. Oh, so not here. So it's coming from here. Then you should notice this the thing is because it's exact rotate based on this axle. So because you already moved that to minus 20, so they will rotate like this round. So the center is should be the minus 20 in the Z axle. So that is looks like it's not what we want. So that means is we want is when we have this wheel in the middle, then we rotate first, then move out. So that means when you make your model in the program, you should consider the order or sequence. So in this code is now you see we should first rotate, then translate. So on here, the difference is you need to make translate first, rotate second. Then let's see. Good. So it's rotate directly here. So if we comment here, you can see. So originally is you first translate that here, but before we translate is we will do the rotate. So like this, or if you comment this one, you can see it's rotate from here. So that is give you a way you can do the troubleshooting or analyze your model. So first you draw our cylinder, then above cylinder you did a rotate, then after rotate you do a translate. So I see. So you move out. So that is the perfect for now. Let's continue. And we try to modify the input parameter of the translation command to make this wheel the front left wheel of your car. So you can think about this. You need to shift this to somewhere in front. Then that we keep this rotate, but we need to make sure this is closer to your car, so it's not this 20. So 20 is too far away. But how much? Here is 10. Then we give our 15. So let's see. So whenever you change something, you can just press F5 to look at that. And then we through this Excel, you can make that to front. When you say front, notice this positive or negative. We want to go to here, then we go to the minus negative 20 or minus 20. Then you can see here. That is the thing where we have putting our wheel here. To add the front right wheel, we will copy this one. So you can see put some comments like this the front left wheel. Then let's copy this right. So what's the difference? To right is almost everything is the same, but they need to move to the Y first in the difference. So only in the Y is the difference. So it's this one. So we put this negative to positive. Then we have another wheel. So that, and they are exact same. Is that right? No. So they are not. The position is not symmetry. So the reason you remember is when we draw the cylinder. So let's common stays. Let's back to here. So you see the cylinder is not in the center like our cube. So we also need to give them our center. So they also have a center parameter. So true. Then after that is let's see. So it should move down half of the edge. So move down 1.5. Then when we have this rotate, they will come to this way. And we also need to give this as a center. Then they come to the same the direction in the symmetric way. So now let's see. They are on the symmetric. Yes. And then we have two. So we add this center equal true. And then complete our the car. So we need another the two wheels. So let's copy that. Now you can see you are starting to have some repeatable the code. So in the later the exercise we will see we can have some functions like any other programming language you can define. Then you can use a parameter to call a function. So first is we see the front, and we should have a rear left, rear right. So what's the rear? So we have these minors. These are the front left, the front right, and the difference to from front to the rear is the X. So first is this is positive. Let's see, we should have another 2. And looks like it's a nice for now. And we also have this in the middle. We should have our axle to connect these 2 wheels. So let's add those. So that is kind of our cylinder. It's a very the long cylinder, but we modify that from here. So translate is fine. So let's see, that will be our long cylinder and will be our thin. And then we should move to the center of these 2 wheels. So that means is we should not move in the Y axle. And then is first is for the front. So let's see. So 5, perfect. Then we copy this. And make that positive 20. That should be coming to here with another one. That's it. Yeah, now we have those all the parts already. So let's save, and we can now remove those transparent. Then that's back to our actual the yellow color or the default color. You should notice is a model above is overlapping between the axles and the wheel. That is equal to half of the thickness of the wheel. So that is the purpose. If the model was created in a way that the wheel and the axle were just touching each other, like this upper and the bottom, that will be our need another similar way, like this minus 0.001. So because when you make this OpenSCAD model, always you need to consider the printable, the result in the 3D printer, because by theory, if you just make that exactly touch only, when you print that into a real the model in 3D printer, they can be disconnected after that. You need to let this model inside a little bit into another. So that's why we need this longer to the this wheel position. And then we have one thing that maybe bother you so far is the resolution. So it's not look quite like a round. Until now, you have been using the default resolution setting. Some other special command in the OpenSCAD language allow you to have full control over the resolution. So since the car is complete, now we can, when you remember, like here is when you do the modeling, better you keep the default because you always need to refresh your the model. You increase the resolution will decrease the performance. So, but since now, as mentioned here, is our car is almost finished on the design, we can increase the resolution to adding the following the 2 statement. So those we will add in the beginning. So starting from $FA1 $FS 0.4. You can see here. So that is the resolution you can adjust. So we add that here. Now it's looks is quite round or good enough. And then try add the comments above on each statement. So we can see here is the front accels, rear accels, set resolution is the car body. The comments is just like those, is not change your code. So that is the second part of this working tutorial. So we have making the things similar like this. You can always copy this to your model, but we do this step by step. So that is the first car. Let's save that. If you want to build this car in the 3D model, actually you can export this SRSTL file. The current tab has been modified since its last render. Do you really want to export? No. So I want to save. And before I go to the export, you need to render that. So you can see here is a render with a sound, and that means this now is ready to export. So let's do the export to the tutorial of this one. So in the tutorial is now you can have these two files. So I will keep uploading these to the repository. So we now have part 1. The extension is SCAD, and the part 2, and also our part 2 STL, which is our model file. So if you are working on the Visual Studio code, actually you cannot directly see the STL, but you can see find is our viewer. So VS Code STL viewer. When you install that, let's see. Then you can see from your file. Now within the Visual Studio, the code, now you can see your model. So this model is actually the STL file, and you can directly send or copy to your 3D printer, and that will be the finished result. And you can adjust how to print that in the 3D printer device. So that is the all the things for this first tutorial. We don't move fast, since I hope is you can get some the slowly understanding on the basic syntax and the grammar of this SCAD programming. So thank you for watching, and next video we will move to the tutorial 2. Have a nice day.